Okay, in today's lesson we're going to talk about properties of exponents, and we have three properties we're going to talk about and have a few examples that I'll give to you. The first one's called the product of powers property, and it says to multiply powers having the same base, add the exponents. And so here's the two examples with just letters and numbers. Here's what we mean by the same base. The base is a, the base is a. So since I have a to the n power multiplied by a to the n power, the bases are the same, I can write one base, just a, and then you add the exponents, m plus n. And so the example over here with the numbers, I have the base 3 squared, and then 3 to the 7th. Okay, so I'll write it as one base, 3, and you take 2 plus 7, which is 9, and there you see your answer, 3 to the 9th. Okay, so here we're going to simplify two more examples, and I'll do these two. Try and show you a little bit about why you add. Okay, 4 to the 3rd, remember, is just 4 times 4 times 4. Okay, 4 to the 5th would be 5 fours. And we're multiplying. Okay, so if you look at what we actually have repeat multiplication with 8 fours all multiplied together. So I could write 1 base 4, and my exponent is 8. And there's your answer, 4 to the 8th. Which, again, how do we get that? 4 to the 3 plus 5. 3 plus 5 is 8, 4 to the 8th power. Okay, on the second example, x to the 4th times x. This could also be written x to the 4th multiplied by x to the 1st. And again, x times x times x times x. And then x to the 1st is just 1x. We're multiplying. Okay, so when you look at your answer, you've got 5 things being multiplied. All of them are x's. So I could write x to the 5th power. And then the rule, the product of powers property says we can take the x and take 4 plus 1. And 4 plus 1 is 5. So those are a couple of simple ones. We'll do a little bit more difficult ones now. Hey, this time we also have coefficients in front. So it's 3 times x squared multiplied by 5 times x to the 7th. Now, we write everything out. That's 3 times x, and 5, and I'm going to have 7 x's. And we're multiplying everything together. So what we do is we just rewrite, and we'll take our bases that are different, the coefficients, put them in the front. 3 times 5, and then all of our x's. There's 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have that. 3 times 5 is 15, x to the 9th. And if you look at a different way you could do that, you're doing 3 times 5, and you're taking x to the 2 plus 7. 15x to the 9th. But that's just showing you how when you just expand out and write without exponents, that's how we get the 15x to the 9th. We took our coefficients and we multiplied them together. On this one thing to keep in mind is that negative x squared is actually negative 1 times x squared. Okay, that exponent 2 is only on the x, it's not on the negative 1. So when we multiply this out, you get 5 x's here, and then you have a negative 1 and 2 more x's as factors. So there are all my factors. Okay, when I rewrite it, put my coefficients, the numbers that are different bases, out to the front. 6 times negative 1. And we have all of our x's here. 6 times negative 1 is negative 6, and then that's x to the 7th power. And again, you're doing 6 times negative 1 times x to the 5 plus 2. And that's where you get the 7 from. So when you have coefficients, the 3 and the 5, the 6 and the negative 1, those get multiplied together. Okay? The like bases can be written as one base, and you add the exponents. 2 plus 7 gave us 9. 5 plus 2 gave us 7. The next property we're going to talk about is power of a power property. To find the power of a power, you multiply the exponents. So in this, we have a to the m power, all raised to the n power. That equals a to the m times n. The example with numbers here, 5 squared raised to the 4th power becomes 5 to the 2 times 4, or 5 to the 8th power. Now, if you simplify this expression, try and show you why this works. X to the 3rd squared would be x to the 3rd times x to the 3rd. And if you think about what that means, x times x times x, and x times x times x. Okay, and those two things are being multiplied together. Okay, and when you do that, I've got a repeat multiplication with 6 factors all the same. I can write the base, which is the same, the factor that's repeated over, x, and my exponent becomes 6, and there's your answer, x to the 6th. And that we got by just doing x to the 3 times 2, and 3 times 2 is 6, so x to the 6th power. Okay, power of a product. Okay, to find a to find the power of a product, you find the power of each factor and multiply. So in this one we have 2 factors, a and b, a times b, raised all to the m power. We could take a and raise it to the m power, and take b and raise it to the m power, and then multiply. So the example, 2 times 3 raised to the 6th power. We can do 2 to the 6th power, and then multiply that by 3 to the 6th power. Okay, or we could end up doing it, you actually just do the order of operations. 2 times 3 is 6, 6 to the 6th power. And if you calculate both of those, you're going to get the same answer. And in this last piece here is one where I have an x, 2 times x raised to the 6th power. And now I can't put 2x any simpler than 2x, so I have to use the property. I take 2 and raise it to the 6th power. I take x and raise it to the 6th power. 2 to the 6th power rather is 64. X to the 6th power is x to the 6th, and you end up with 64x to the 6th power. Now I've got a few examples on the next page. All right, on this one, we have 2x to the 3rd squared. So I could write 2x to the 3rd multiplied by 2x to the 3rd. Okay, that's what it means to square something. And when I do this, now I can do 2 times 2 times x to the 3rd times x to the 3rd. 2 times 2 is 4. X to the 3rd times x to the 3rd would be x to the 6th. Okay. Another way to look at it, if you apply the properties, 2 squared multiplied by x to the 3rd squared. 2 squared is 4. X to the 3rd squared would be x to the 3 times 2. 4x to the 6th. Right, so it doesn't matter if you expand it out and make it as 2 factors, 2x to the 3rd times 2x to the 3rd, and then manipulate it that way, or if you apply the properties. Basically now we have the coefficient 2. You have to make sure you square the coefficient, 2 squared, so we got 4, and then take the base, x to the 3rd, and raise that to the 2nd power. So we got x to the 6th. This next one, you either have negative 5x times negative 5x times negative 5x. Okay, this becomes negative 5 times negative 5 times negative 5, x times x times x. When you multiply the three negative 5s, you get negative 125, x to the third power. Okay, when you apply our property, we get the same answer, okay, but we can get it by going negative 5 to the third power multiplied by x to the third power. And that is negative 125, and that is x to the third. And there's that answer. Now the last example, okay, we have to do a couple of things. We follow order of operations. We're going to do this part first. Okay, 4xy multiplied by 4xy. And that's what 4xy squared means. Okay, and then we're going to take that answer and multiply it by negative xy to the third. Okay, we could do this all together at one time if you want. Take all of the coefficients, 4, 4, and remember this is negative 1. 4 times 4 times negative 1. Okay, and then we would take x times y times x times y times x times y times y times y. And when you do all of that, okay, this is going to be negative 16. When you do the part in green, we've got 1, 2, 3 x's. That's x to the third. Okay, and then your y's, y to the fifth. Okay, and so that gives us the answer, which is negative 16 x to the third, y to the fifth. All of these properties are really properties that you really already kind of know if you just understand what it means to square things, cube things, write it all out and kind of expand it and then put it back together using the exponents.